Vivaakan sir. I think Dean sir arrived, so we can start.
Good evening to all the participants. No, I hearty welcomes all the participants and our today's speaker Gopal sir, and also our today's chief guest Dean sir. Dr. G. Bhupen Raj sir is a soil science expert, currently working serving as Dean of School of Agriculture at University, which is our collaboration partner Warangla Tengla. Sir is working since October 2021. He has earned his MSc PhD in soil science from Acharya NG Raga Agriculture University. Sir is having 38 years of experience in this field. Now I request Dean sir to say a few words to our participant who is eagerly waiting for you, sir, to listen from you few words.
Good evening to all. Is it audible?
Yes, sir.
Yes, sir. Yes, sir. Audible.
Okay. Good evening to all participants and guests of this today's function. My dear guests and esteemed faculty and participants from across the country and my dear colleagues. It is indeed a great pleasure and pride for me to join you all in inaugurating this national training program on biometrical tools in crop improvement. At here SR University, we have always believed in fostering innovation, research excellence, and hands-on training. The training program exemplifies our vision of blending theoretical knowledge with practical applications. The agriculture sector is generating massive amounts of data, and it is only through proper biometric and statistical analysis that we can extract meaningful insights. Such insights will guide us in breeding high-yielding, climate-resilient, and farmer-friendly crop varieties. I am delighted to note that this program has drawn participation from scientists, scholars, students, and faculty across India, reflecting its national relevance. The topics from basic designs of experiments to modern geomics based approaches are timely and essentials for capacity building in the agriculture research community. I encourage all the participants to take this as a platform not just for learning but also for networking all and collaboration. Agriculture today needs collective efforts, and programs like these act as a bridge that connect knowledge with practice. On behalf of our School of Agriculture and SR University, I extend my warm welcome to all the participants and declare this training program open. I sincerely thank 360 Research Foundation and all collaborations for making this possible. Best wishes for the fruitful and impactful training journey ahead. Thank you very much. So before starting this program, just I want to share a few things about our SR University and School of Agriculture. SR University, you know very well, recently through NIRF ranking, it has got NIRF ranking through all over the India, 91 ranking. Recently, yesterday, the results were declared. So it is consistently since last 4 years, our SR University is securing below 100 rank. It is 91 to 98. Last year also 98. Now it has got 91 this year, and 100 to 150 band among the university. So this 91, this ranking, NIRF ranking is under the engineering category. Then regarding our School of Agriculture, we have very good instructional form, very good laboratories, and very experienced staff. And we are mostly concentrating on hands-on experience rather than bookish and classroom knowledge. We have very good protective structures in the form, and we have MSc program and PhD programs in different departments. And our staff have probably, even though with our School of Agriculture, it was started during 2020 only. That is just young college, and our university is also young university. It was started during 2020. In a short of span time, it has secured very good NIRF ranking. We are also expecting NAC ranking, very good ranking. We are expected the results very soon. Then our School of Agriculture, we have our staff has published many Scopus publication, 100 plus publications, and about 20 patents they have published. So a lot of research work is going on, and student activities are also going on. So just I wanted to share this little information with all participants and your this scientists and students across the country. Then coming to this 360 Research Foundation, they are very cooperative and we have collaboration with them. So constantly we are arranging this type of programs. I thank 360 Foundation for organizing this type of very useful programs for the sake of scientists and students and farmers and other stakeholders. Thank you very much.
Words of thanks, sir, for your valuable words. Sir, not only from India, from several countries, other countries also participants have joined this time.
Yes, yes, very good, very good. Very good to know that across, not only from our country and other and foreigners are also abroad also they are participating. It is very good to know.
To listen.
In fact, that one of my assistant professor who worked under me earlier, he has recommended two participants from his own, I mean that Bihar state. They are also participating now, soil scientists.
Thank you so much, sir.
And one is from abroad. One is from abroad.
Thank you so much, sir. Now our second chief guest is Dr. Hirakant V. Kalpade, sir. He is expert in plant breeding and head of Department of Agriculture Botany at College of Agriculture, VNMKB. He holds a PhD and over 2 decades of professional dedication in the field of genetics, plant breeding, and molecular breeding. Gopal sir is our second sir is available.
From tomorrow he will be there, sir. No problem.
Okay, no problem, sir. We welcome to our second chief guest also. He will be available for you all from tomorrow. Now I request Gopal sir to begin the session.
Yeah. So good evening, everyone, and welcome to all. So first of all, I will thank to Dean sir for his valuable words and valuable time. So welcome all participants, my friends, and some and colleagues. So this is second time we are collaborating with 360 Foundation and we are organizing this course. So this course will not only deal with the statistical analysis, so right from what is the concept, how we have to record the data and how we can analyze, and after analysis, most important thing, how to interpret the analyzed data. So everything one by one we will see. So means we'll get through the concept. After that, how to analyze, how to arrange the data. Right from concept, data arrangement, analysis, what are the different output files we'll get, and how to interpret one by one. So everything we will see. So yeah, screen is visible.
Yes, yes, sir.
Yeah. So our training topic is biometrical tools in crop improvement. So as this is first day of training, so first we'll go through the introduction to biometrical tools used in agriculture, or you can say as crop improvement. So first I will go through the PPT. Then after that, after completion of PPT, then we will discuss and we will complete this introductory part. So as an agriculture student or as an agricultural researcher, we are came across a complex biological data, some replicated data, some treatment-wise data with number of treatments. So now first, what is meant by biometrics? So biometrics is applications of statistics and mathematical method to study whatever the biological data we have. So we will apply the statistical and mathematical method to study the biological concept. So for what we will study or for what we will apply? So to help in decision making. So we have the recorded data, we need to make some decision. Like if we have some 100, 150 treatments, we have to decide. So which treatments are better, which treatments we need to we need to discard, which treatments we need to take forward. So that decision making, for that decision making, we need to apply the statistical and mathematical methods to study the biological concept. As I have already told, second objective is data interpretation and research validation. So this biometrics will help in decision making, data interpretation and research validation. So whatever the data we have, so on that basis, it will helpful for us. Then second is, what are the objectives of biometrical tools? So as in crop improvement, so this all crop improvement, whatever it is based on one single word. That is variability. So what is meant by the variability? Whatever the differences available in our plant population or whatever the germplasm we have, the amount of variability present. So as this biometrics is application of statistical and mathematical method, so this biometrics will helpful in analyzing the amount of variability present in our plant population. Again, it will be helpful to estimate some genetic parameters. Like first one is heritability, second is genetic advance, and third is correlation and path analysis. So all these genetic parameters you can calculate by using the biometrical tools. Then next objective is comparison of treatments of and genotypes under different conditions. So likewise, not just in plant breeding, generally in agronomy, in soil science, we used to compare different treatments under different conditions. So in that also these biometrical tools will be helpful. And after doing all this analysis, we can select the superior treatments or superior genotypes based on our analysis. Then what is the importance of these biometrical tools? So the basic importance is prediction of yield. Then it helps in planning of breeding programs, that is selection of parents. If we are evaluating hybrids, it will helpful in selection of hybrids. Like we used to evaluate the hybrid multi-location to study the stability, which hybrids are stable and which hybrids are not performing well throughout the environment. So this by the use of this biometrical tools, we can select which hybrids are suitable and which hybrids we can carry forward to develop a breeding population. So these biometrical tools, these are, again, it will guide us. So which experimental designing is suitable in what situation? So suppose 15, 20, 30 genotypes are there. I'm saying in case of breeding, if we have 20 to 40 genotypes, generally we will go for 3 replication, randomized block design, 3 replication, 20 to 25 plant population. So likewise, it will guide us. So which experimental design we need to select. And last, it will ensure the valid scientific conclusion. That is, it will lead to some decision making. So these are all, that is yield prediction. Again, biometrical tools will help in planning of breeding programs. Then next, it will guide in selection of experimental design and data analysis. And last, it will ensure us some valid scientific conclusion. Yeah, so now we'll go through, as this is introduction to biometrical tools, we will go through one by one biometrical tools. First, at basic level, we will do descriptive statistics. So in descriptive statistics, we will go for mean. Mean means we will calculate the average of whatever the number of treatments we evaluated. Then range, that is maximum value and minimum value. Then standard of deviation. So standard of deviation means which treatments or which genotypes are deviating from the actual mean value. Then we will go for standard error, critical difference, and coefficient of variation. Then second, we'll go for ANOVA. So that is analysis of variance. So in analysis of variance, generally it will divide whatever the amount of variation, it will divide into 3 components. That is, first one is genotypes or your treatments. Second one, replication. And third one, error in case of randomized block design. So in this, we'll compare the treatments or varieties. Then third, correlation and regression analysis. In this, whatever the amount of traits we studied, we will study the relationship among different traits. So likewise, for example, if we are dealing with fruit yield, in some, say, for example, crop is okra. If we are dealing with fruit yield of okra, then what are the different characters which are directly responsible or which are directly related for the fruit yield? That is, first one, number of fruits per plant. Number of fruits per plant, more fruit, more yield. So that is the correlation and regression. And then second, path coefficient analysis. That is direct, that whatever the amount of variation, it will divide into direct and indirect effect. That means just now I told number of fruit per plant, it will directly affect the fruit yield. Right. So again, number of nodes per plant. So more number of nodes, more number of fruits, and ultimately it will affect fruit yield. So that is, some traits directly it will responsible, some indirectly. So that interpretation, it is path coefficient analysis. And as I told you, some genetic parameters, that is heritability, genetic advance, genotypic coefficient of variation and phenotypic coefficient of variation. So these all biometrical tools we will see in one by one in separate classes. So then the most important part is experimental designs. So basic designs are CRD and RBD. That is complete randomized and randomized block design. But nowadays, split block designs are there. Alpha lattice, augmented. So lots of experimental designs are there. Then in advanced tools, principal component analysis, then cluster analysis. In this, we'll divide the different genotypes into different clusters. And the next is molecular data analysis. So here, as I already told you, what is mean? Mean is average performance of the genotypes. Standard deviation means spread of data. So what is spread of data? The number of genotypes, the mean of number of genotypes deviating from the average performance of your population. So next is coefficient of variation, and CD means critical difference. So it will deal with variation among the treatments and variation among the replication. So generally in field, as far as field experiments are concerned, this this coefficient of variation will be roughly it is more than 6. And in case of lab experiments, it will be like in between 2 to 5. And then this descriptive statistics is, the use of it is evaluating stability of traits. Then what is meant by analysis of variance? So it will test the significance of differences. So as I already told you, it will divide the significance into 3 sources of variation. That is replication, second one is treatment or genotype, and third one is error. So if your replicated data is having a proper variation among your treatments, so whenever you will analyze the ANOVA, your treatments mean sum of square will come as a significant. And your replication mean sum of square, it will come non-significant. So what are the different components? Treatment means sum of square, error means sum of square, and this significance level will be decided by F test. So what is the application of ANOVA? So it will test whether whatever the new varieties are there, it will outperform the checks or not. So on what basis? On the basis of significance level. Yeah. So next is correlation and regression analysis. So what is correlation? It measures the association between the traits. And what is the regression? It predicts the dependent variable from independent variable. So this is the difference. What is the application? Application is for both correlation and regression. It helps in identification of traits which are mostly contributing to yield improvement. So the objective of doing correlation and regression analysis is identification of the particular traits which are contributing mostly to yield improvement. Hope I am audible to everyone.
Yeah, you are audible, sir. Yes, sir.
And after correlation, we will go for path coefficient analysis. So actually this path coefficient analysis is nothing but extension of your correlation. So in correlation analysis, in this correlation analysis, we will interpret like fruit yield is this number of fruit per plant will be directly correlation with fruit yield. Positive significant or positive non-significant correlation with fruit yield. But in path analysis, as it is an extension of correlation analysis, this path analysis will divide the correlation into two parts. That is direct effect and indirect effect. So for example, here I have given like grain yield depends directly on spike numbers. More number of spikes, it will directly affect to grain yield. But grain yield is indirectly depend on tiller count. So like this, path coefficient analysis will divide this correlation into two. The traits, which traits are directly affecting the grain yield and which traits are indirectly affecting the grain yield. So we'll get two different conclusions. So then we'll come to genetic parameters. So in this genetic, there are different genetic parameters like genotypic, phenotypic variance, then heritability. So this heritability will directly related to genetics. That is, heritability is nothing but it is proportion of variation. Proportion of variation that is due to genetics. Then next is genetic advance. So what is genetic advance? Genetic advance is expected improvement in whatever the plant population you evaluated. So expected improvement through selection. Like we all know, breeders are doing selection and rejection. So whatever the expected improvement through selection, that is genetic advance. So this genetic parameter will help the breeder to decide the selection strategies. So means in what ways breeder can proceed with selection of genotypes or selection of particular plants. So these genetic parameters will help him to decide the selection strategy in further generations. So then we'll come to experimental designs. So as I told you, there are different designs. That is first, completely randomized design. Generally, it is used for lab polyhouse greenhouse studies. That is for controlled condition. In RBD, that is randomized block design, will be used for field experiments. Then lattice design, that is alpha lattice design. Normally now in plant breeding, it is used. So this design is followed when you have large number of genotypes. That is, in alpha lattice, we used to do almost 250, 300 genotypes also. Then split plot design, it is there. When we have multi-factor experiments, then we'll go for split plot design. Then again, augmented block design is there. So in this augmented block designs, replications will not be there, but whatever the checks are there, either 3 or 4, so it is replicated throughout the blocks. So in place of replication in augmented block design, whatever the genotypes are there, suppose you have 70 genotypes and 5 checks. So 5 checks. So what I will do to that 70 genotypes? Sorry, 75 plus 5. So what I will do? I will divide that 75 genotypes in different blocks. So let's see. Each block will contain 15. So 5 blocks, 75 genotypes. And in that 5 blocks, I will replicate this 5 checks. So that is the layout. So 15, 75. And this, whatever the 5 checks I choose, so I will replicate that 5 checks in each block. Yeah, so then some advanced biometrical tools. So as I told you, first principal component analysis. Second, cluster analysis for grouping of genotypes. Then in advanced biometrical tools, nowadays, many publications you can see if you will explore Google Scholar ResearchGate, that is related to stability and adaptability studies. So there are different, earlier we used to go only Eberhardt and Russell model for stability analysis. But nowadays, there are different models like AMI analysis, then BLUB. Earlier, if you will go through the history of BLUBs, it was only used in animal breeding. But nowadays, this basic linear unbiased predictions, they are used to study the stability analysis in plants. Then, weighted average of absolute score, that is WAAS model, and GGE biplot. So all these 4 models, apart from Eberhardt and Russell, so total 5 models are there through which we can study the stability and adaptability concept. And next is marker trait association analysis. It is useful in genomics and molecular breeding. So in marker trait association, we will go for either QTL mapping or genome-wide association studies by using either SSR markers or SNP markers. So nowadays, both concepts, that is QTL and GWAS, QTL mapping will generally, it will do by using ICI mapping software, or in institutes like ICRISAT, they will go for RQTL. And this genome-wide association study, you can do it in R by using the methods like GAPIT, FARM-CPU, Blink, Super GWAS. And along with this too, you can go for genomic selection also, for selection of your genotypes. So what are the applications in agriculture? So in crop improvement studies, it will helpful. These biometrical tools will be helpful in selection of parents and hybrids. Then, as far as multi-location trials are concerned, these biometrical tools will be helpful for stability analysis. And this utilization of these biometrical tools will be helpful in analyzing the data related to stress tolerance. So now this climate is fluctuating everywhere. So these stress tolerance experiments are very important. And again, in quality traits evaluation, it will be helpful in protein and oil content. Now, what are the challenges? What are the challenges and limitations? So as these biometrical tools, as I told you, require large and precise data sets. So data sets will be large, like if you will go for marker trait association, many PhD scholars I saw in participants list, many molecular breeders are also there. So this marker HapMap file is having minimum 40 or 50,000 markers with 500 genotypes, phenotypic data. So data set will be large. It requires large data sets. And your phenotypic data should be precise. Then second, you have to choose the correct experimental design based on your objective. If you don't know how to interpret the data, so maybe it will lead to false conclusion. And now it is many if you will go through ResearchGate and these things, you will came across some papers like machine learning in crop improvement. So that tools are still evolving. Genomics, it is there, but artificial intelligence, we have seen some papers, but I think it is still evolving concept. So as conclusion, in crop improvement, as far as my personal opinion is there, a person with crop improvement experience must know the biometrics. So unfortunately, many people, some people are there who don't want to learn or some because of some other issue. But as far as my personal opinion is there, person with crop improvement experience or those are doing MSc, PhD related to crop improvement like agronomy, soil science, breeding, any department, he should know the biometrics as it is a backbone of agriculture research. And the future, as I already told you, integration with artificial intelligence and big data. So this biometrics is the backbone of agriculture research. And it is not like I am telling you now and you will be perfect. If you want to perfect in any biometrical tool, you need to practice it daily. It is not like it is not a theory like heredity, transmission of characters. It is not like that. You need to practice daily. So this is all about introduction of biometrical tools. So now on this introduction, if anyone wants to say anything, you can speak.
Hello, sir.
Yes, madam.
Sir, can you please explain bluff with some example?
Yeah, madam. For what purpose I prepared this? Now we'll go from tomorrow onwards. We'll start with experimental design. I hope everyone got the schedule.
Yes, sir, we got it.
Yeah. So right from experimental design to genome-wide association study. So this total we will cover.
Okay, sir. Thank you, sir.
Yeah, with all the examples, you will get the data set. And on Saturday, as you have, I think, already seen, we have kept one test. So that test, it is not like I will give you some objectives and you will fill. So objectives also will be there. And along with that, whatever we will cover from Monday to Friday, I will give you some with one data set and you have to analyze it and you have to send the results to me. So on every Saturday, this type of test will be there and you have to submit the data, whatever the output files will be there, you have to submit to me. If any error will come, then on Saturday, you can contact me. I will solve that on spot. So likewise, this plan is there.
Just
Yes,
1 minute,
sir.
sir. Based on your attendance, number of questions you have asked, your participant, your test result, at last we are going to select 10 peoples. They will get a special award. So please be in the session sincerely and learn.
So means like some inputs I got when I took my last training. So some inputs I got, sir, you told how to analyze the data, but what to do before that, how to arrange the data, how to record the data, what is the concept, what is the stability. Just now, madam asked, what is the blub? So for this reason, I have planned the program like in such a way, you will get to know the concept, you will get to know how to record the data, how to analyze and how to interpret. So means your theoretical concepts will be clear along with the statistics. So now we'll go for some downloading of RStudio. So we need to, so new participants, we need RStudio and R software. So can I share the links in chat box?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Hello, sir.
Yes, sir.
Yeah, thank you for the introduction. So I just want to ask, you have mentioned some of the experimental design that will be treated, but you have not mentioned partial replication period. So I don't know whether this one will be considered too.
No problem, sir. I have not mentioned that augmented also. We will cover, sir, as much as we can from your side also. If we will miss something, just you can give your inputs.
All right, thank you.
Yeah. So I have shared both links, R software and R studio. Just download both. And those have already have, just check the version, whether it is 4.5.1 or older. If it is older, just update it.
मरने के बारे में तो हरगिज नहीं सोचना चाहिए।
So I have shared both links in WhatsApp group also. So you can access from there also.
Hi, sir.
Yes. Yes, yes.
Yeah, sir. Actually, I have installed this R what you have sent. It is already it got installed and showing on the screen. So, like after opening, it is showing as R console.
Our software you downloaded, na?
Yeah, whatever link you have given, I
Yeah.
have.
So now download that R Studio.
Okay, where I can get
Yeah.
that link?
In WhatsApp group also it is there, and in chat box also both links are there.
Acha, okay.
Yeah.
Both links are separate, right?
Yeah. Both links are separate.
Oh, okay.
Yeah.
Hello, sir.
Yeah.
If
Tell me.
okay, in case I already have the R software in
Yeah.
my,
So no problem. Just check your version of R Studio, whether it is latest or old.
yeah, it's not long
Let
I downloaded it
Yeah, latest
with
is
the R Studio.
4.5.1. Latest version is 4.5.1.
Okay, let me check.
Yeah. Yeah. If it is older, just you can update it.
Okay,
Yeah.
Arun Mehta, I have shared the WhatsApp link in the message. If anyone have not joined, please join it.
yes, it is the latest one.
Yeah. Then no problem. No need to
Okay,
install it again. Yeah.
okay, thank you.
Yes. Rishi Patel. We can go for stability of hybrids. We will cover that in our stability class. With all the models, whatever I have listed, with each and every model, we will do it. No problem.
Good evening, sir.
Yes, madam.
Sir, I have one doubt.
Yeah.
Can you explain me the basic difference between genetic advance and genetic gain?
Yeah, madam. Yeah. 1 minute.
Hello, sir.
Yeah.
Good evening, sir. Can you please explain the three actually, genetic gain, genetic advance, and response to selection?
Yeah, that only I will explain. Just give me 5 minutes. Just let them complete the installation. After that, I will give the difference.
Okay, thank you, sir.
Yeah, yeah.
Hello, sir. Hello, can you hear me?
Yeah, yeah, yeah.
Right. Thank you for the presentation. Yeah, I want to ask. Sorry, I was on the road, so I could not get everything, but at least I got
Okay,
most of the
okay.
things you discussed. So,
Okay.
in experimental design, basically we look at special nature of the soil and everything that we do in analysis in designs, which data sometimes contain row and column. So will the training cover special data analysis where um, row and column design of the field will be plotted, and also the variogram will be explained, so you can have a clear explanation of the variogram to know how we have a large error in the field design. Did you get my question?
Sir, actually, your voice is not clear.
Oh, is it? Can you hear me now?
Yeah, yeah.
Okay, so I was asking if you will also include a special data analysis where you plot variogram and also explain the concept of that variogram for us to use it to know the variability and the field design when incorporate a row and column.
Yeah, you are saying about dendrogram, no?
Yeah, variogram, yeah.
Yeah, yeah, yeah. So
Variogram in this special analysis.
we have that say, class sir, about special about cluster analysis. Along with that basic tortures method, we will go for K mean clustering and H clustering also. There are also different methods of clustering, so we will cover each and everything.
Okay, so I was also looking at the AR model in spatial analysis, where we also plot the variogram to show the spatial
Yeah, yeah,
field
yeah.
design.
No
All
problem,
right,
no
all right,
problem. We'll cover that also, sir. No issue.
all right.
Yeah, good evening, sir.
Haji, Dr. Sahab.
Actually, what happened, Art Studio has already been installed, but using our software, my network is very slow. 85 MB is only remaining, but showing 2 hours to download. So my question is that if I am unable to install today, so
No
is there
problem, sir. For what I am telling you today, na, so that tomorrow we can save that time.
Okay.
So by
And
night
another
you can
thing is,
download, no problem.
okay. And the recorded session, is there any availability in the site or other way so that we can get in future also?
डॉक्टर साहब आपका आवाज क्लियर नहीं है.
बोल रहा हूँ की recorded version, आपका इस सेशन का recorded version can we avail later in any platform so that we can learn in future also. And another thing is,
it will come to your mail, sir.
okay, thank you, because I'm also in the
Yeah,
job,
recorded
so every day.
Recorded videos will be there on your mails.
Yes, okay, thank you so much. Actually, maybe 1 or 2 days I may not be joined because I'm in the job, and 6 to 8 is just after reaching home. Immediately I have to sleep. So thank you so much.
No problem. Videos will be there, so you can use that videos later on also. No problem.
Okay.
Yeah. So regarding some participants ask regarding genetic gain, genetic advance, and third one is response to selection. These are the three different terminologies. They are not single. They are not common. So what is the genetic advance? First we will say genetic advance means whatever the amount of improvement if we complete one cycle. After that one breeding cycle, what is the amount of improvement is there? So that means expected actual improvement in the mean performance of that particular trait. Whatever this, suppose we have selected 100. Earlier we have 100. After one breeding cycle, we have selected 100. So what is expected actual improvement in that selected individual with respect to particular trait? So that is called as genetic advance. And now next is what is genetic gain? Genetic gain is the rate of improvement. Genetic advance means actual improvement. Genetic gain means rate of improvement and response to selection. So response to selection means difference.
Sir, your voice is not clear.
Yes, sir, your voice is breaking.
Yeah, sorry for the network interruption, guys. Yeah, so what I am saying is now am I audible?
Yes, sir.
Yes, sir. So what I am saying is the difference between the three terms, that is, first is genetic advance, second is genetic gain, and third is response to selection. So genetic advance means your expected actual improvement in the mean of selected individuals as compared to your original population. So that is called as genetic advance. That is, we used to say some 10% improvement of mean over base population. So that 10% is genetic advance. Then the rate of progress or rate of improvement in that population mean after one breeding cycle or after 1 year. As in each breeding cycle, we will carry the selection activity. So because of that selection activity, the rate of improvement in the population mean after completion of each year or each breeding cycle. So that rate is nothing but genetic gain. And third is what is response to selection? That means whatever the difference between progeny mean of selected individual and original population mean. So that difference is called as response to selection. Hope you all got this difference.
Yes, sir.
Hello.
So I hope, yeah, Raviraj sir.
Yes, sir. Sir, if I am right, how I perceive your what you have explained is expected genetic advance we can calculate before conducting a selection, whereas genetic gain we can estimate after completion of one round of selection. Am I right?
No, before selection means what you want to say?
Means like we are expecting how much genetic advance we are going to get. So it is expected amount.
Expect your expected is different, but if you select, suppose you have some 50 germplasm and you have selected some 50 plants from that your core germplasm, you have selected some 50 varieties and you have evaluated for some genetic parameters. So from that you can calculate genetic advance.
Okay, sir.
And genetic gain means the rate of improvement from that core germplasm up to that means whatever you have completed that one breeding cycle, means from that core germplasm you selected 50 plants. So the rate of improvement in the mean population of that, so that is called a genetic gain. And difference between your mean of 50 plants and the original population, that difference is called as response to selection. That means on you have selected 50 plants, so that mean performance is more or less, so that difference is response to selection.
Okay, sir.
So it is not actually a quoted like SRF, so I will cover the theoretical. So it is not SRF classes. It is, I am covering theory, data, analysis and interpretation. If I will not cover theory, no, these students will not understand the interpretation. So that's why I am covering theory.
Hello, sir. Can you question?
Hello.
Hello, sir. Can you tell me the I am agronomic and
Your
can you
voice
explain
is
the?
not clear.
Sir, I have one question from
Yeah.
agronomic department. Yes, sir. Sir, can you RBC design data in agronomic
You
department?
will get one by one as we have topics. You will get the data set. I will tell you how to analyze. And
Yes, sir.
in test, you have to do it. So everyone completed the installation of R and R Studio?
Okay, sir. I have installed.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So just open now, open R Studio.
Yes, sir.
So just if you have, you can search in this quick search bar, RStudio. So like this window you will get. So here you can see the version of R, that is 4.5.1. So like this is RStudio. So this is our working environment. So now you have downloaded two software. One is R software and second is RStudio. And we have to do each and every analysis in this RStudio. This R software you downloaded, which will act as a base to run all the required analysis. So now,
Sir,
yeah.
this I didn't get the environment and all those.
RStudio like this, you can see the screen.
So from the right corner environment history connection, that tab is not visible in here.
So have you downloaded both R software and RStudio?
Yes, sir.
So open RStudio. After downloaded, installed.
Yes, sir. Installed.
Open RStudio. So is it visible like this?
It was coming, but this environment history, these tabs are not popping up right.
So just close it and open it again. Yeah, no problem, Vincent sir. Just you can install in morning also, no problem.
Hello, sir. Good evening.
Yeah, yeah.
Sir, actually, I have downloaded RStudio from the link which you have shared.
Yeah.
But when I am opening RStudio, it is showing version 4.3.0. It is not showing what you have shared, 4.5 something.
Then I think you have downloaded old version from there.
Actually, the link you have shared, I have downloaded from that only. And when I was downloading, it popped up with 4.5. But now when I'm
So like
opening
this, see the screen, Ankita.
Yes, sir.
So here, this link you click.
Sir, there is one more from point one also there is one link in download and install R.
So this link, this RStudio.
I have downloaded that one.
So just install it. Just install this. This is the latest version.
I have done the installation as well. installation is done of both the R software as well and the R Studio also, and also the link now you mentioned on the screen. I have downloaded from the same link only, but it is showing 4.3.0, not showing the current version you are talking about.
So just once again you can download, just uninstall it and download it again.
Okay, sir, I will try.
Yeah.
Okay, thank you.
So whoever are facing the problems in downloading, it is just they cancel that download and download it again. The download will start in a normal way. Yeah, so in WhatsApp group, I have shared 2 files. Just you can download that. Download the both files I have shared in WhatsApp group.
Sir, it was showing like that.
Rajendra, don't open R software, open R Studio.
Acha, okay, sir.
Your R software will act as a base for R Studio to run all these analysis. So if you have your download or installation is complete, download both the files I have shared in WhatsApp group, one text file and one Excel file. Those who are not there in WhatsApp group link is in chat box. So you can join. So see, first I will 2-3 things I will tell you. Just see this and then you can do it. So as we'll get, this is our R Studio environment. So in that, now as I have shared, as I told you, I have shared 2 files. One that is this one, name as the traits. So those who have completed installation and everything, just open this Excel file. And tell me how many total number of genotypes are there?
44.
Replication?
3.
Okay, so this data set is containing data of 44 genotypes, 3 replications, and 11 characters. So like this is days to first flowering, plant height. So I made it short form of all these observations. Later on, after analysis, after preparing table, you can put the long form below at the table. So no need to give it, it will make some diagrammatic representations complex. So here you can see the data arrangement. In first column, you have to mention genotypes. Second column, you have to mention replication. So here you can see the arrangement of data. Genotype 1, replication 1, 2, 3. Genotype 2, replication 1, 2, 3. Genotype 3, replication 1, 2, 3. So can anyone tell me what is the use of these replications? Why we are going with replications in experimental designs?
To reduce the error, sir.
Reduce the error.
Okay.
To check the stability.
And still after that, still we will get the standard error. So what is that standard error? If we are following experimental design proper guidelines, if we are going with proper replication, still we are getting this standard error. So what is that standard error?
Maybe
means
due
what?
to environmental factors.
Yeah. So here 44 genotypes arranged in 3 replications, and these are the 11 quantitative traits we recorded. So total number of columns here are 13. First column is genotypes, second column is replication, third column, from third column onwards, observation started. So just see genotypes. As our software is very case sensitive, so you need to type genotypes. If you will type genotype, again you need to see the script and you need to edit in the script also. Now we will see one by one. So this is the file, and secondly, I have shared one text file. Just open that text file. So this text file contains R code for analysis of analysis of variance for randomized block design, estimation of genetic parameters, estimation of genotypic and phenotypic correlation, estimation of genotypic and phenotypic path coefficient analysis. So all these 3-4 aspects we will cover in this code, right? So first of all, just install this variability package. Whatever I have highlighted, run this first command. Just copy that command and paste in your environment. Like this, paste it and press enter. That installation will start automatically. So installation of this, just you can see the first, I will show you. After that, you can do it. So again, one thing you have to remember, whenever you will install any package, not just this, any package, whenever you will install in R, after installation, you need to run the library command. That is library. Here we have installed variability package. So library variability. Okay, so we have installed the required package for our analysis. What are our objectives? First, we will go for analysis of variance for randomized block design. Second, we will go for genetic parameters. Third, we will go for correlation analysis, and fourth, we will go for path analysis. So after installation of package, now we will move towards second step. Second step is setting up of working directory. So working directory means what? You have to create one folder.
Hello,
In
sir.
your computer. Yeah.
Sir, I have downloaded the version 4.5.1, but why is it showing that please download and install the appropriate version of R tools before proceeding?
Yeah, I will come to that. Just let me complete this because you need R tools also. So I will come to it.
Okay, sir.
Yeah, so now we have installed variability package. So now second step is setting up of working directory. So for setting up of working directory, you need to go to session. Then here set working directory option is there. After that, you need to choose the directory. Then the required folder. Now I will set desktop as my working directory. So I have set up the working directory desktop. So what I will do, I will paste this, I will copy this data and I will paste in my working directory. So after setting of the working directory, whatever the output files will come, that output files will automatically will be saved in your working directory folder. So now next step is how to import the data set. So for that, here on right side, you can see one tab that is import data set. So here you can click. Then from Excel. Then after that, you will get this window, import Excel data, then browse. Then you have to go to your working directory. You have to search the file. So this like this, it will display. And then simply you have to import it. So here you can see 13 columns are there, including genotypes and replications. Your data is imported into the R software. So now after that, simply you need to. So now this importing data step already we have completed. Instead of going for this code, we have done this importation with this tab. So again, no need to go with that code. Then again, first we will go for genetic parameters. So simply you need to copy this command and then you need to paste it. Now after pasting, just cross check it. So now our first column is, just here you can see, our first column is genotypes, correct? Second column is replication, correct? So here you need to change your file name. So it is default file, that is Word data. So your file name is traits. So you have to change everywhere. So total number of columns are 13. So here first I will change the file name. Then, so now see, what is the meaning? Genvar means genetic parameters. Our file name is traits and we are telling the software from third column to 13th column, observations are there. So from third to 13th column, whatever the data is present, we need analysis of that. And what are our factors? First factor is genotype. Second factor is replication. So if just after this, you need to press enter. Again after that. So directly you can copy all these three commands. So in this environment also, you will get the analysis, and in your working directory also, you will get this text file. So whoever have downloaded it clearly, just they can do it. And for those who are the software is asking R tools, just I will share one link. First you can see the screen. R tools download like this. So So this is the link. Just you need to click. After clicking, just download the R tools for 4.5. So I will share this link in WhatsApp. So just use that link and download the R tools. Those who have required, those who have not required, just complete the analysis up to this. If any error will come, just let me know. So anyone got any error while installation of variability also? That also you can let me know. Yeah, so just see once. Once again, I will revise. So this is our file. Not this. So this file I have shared with you. So this file contains 11 quantitative characters, right from days to first flowering to grain yield per plant. First column is genotype, second column is replication. 44 genotypes, 3 replications. And just here, you have to take care in the arrangement of data. Like 44 genotypes, you have to arrange in this way. That is genotype 1, replication 1, 2, 3. Genotype 2, replication 1, replication 2, replication 3. Replication should be vertical 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, like that for all the 44 genotypes.
Hello, sir.
Yeah.
Okay. So after installing the variability package, so
Yeah.
the next step is to go to session and set your working directory, right?
Working directory. Yeah.
Okay.
Second step is you have to set up the working directory. After that, in that working directory, you have to make one folder in your computer. You have to select that. After that, that working directory, it will set. And you have to put that input file also in that same folder. So likewise, here you can
From
see
January,
desktop.
Sir,
Yeah.
from January,
sir,
One by one,
how can,
you can speak. Yes, Neil.
sir, how can I set working directories? Actually, I got problem.
Just see the screen. Just here, you can see the session tab on top. So just click on the session. You will get one option, set working directory. So if you will click, 3 options will come. Last here, choose directory. So here you can choose the any folder like desktop or downloads,
directory.
pictures, anything
Yes.
you can. Yeah. So anything you can select.
Okay, sir. Just open option, no?
Yeah.
Sir,
So
so after,
session, set, then choose. Then select. Now in my case, I have set up desktop as a working directory.
Okay.
So you
So
can
after
set up
January,
any different
Okay,
folder.
sir. Thank you, sir.
Yeah, Rajendra, you are saying something.
after making January and renaming it as a something you told us, sir, from then you can once again.
So see, so after importing the data set, you need to go straight away for estimation of genetic parameters. because I have given the commands for data set import also. You can do that also, no problem. But this is the simplest way of importing the data set.
So
after that, yeah.
Okay, after choosing the desktop, that's inserting the working directory, are we going to select any file like?
No. That Excel file I have shared in our WhatsApp group.
Okay.
That is your input file. That is the data file what we have required for this analysis.
Okay.
Yeah. So after the importing the data, just you need to go for estimation of genetic parameters. You need to copy this first line command. So just see in this text file, here this first line command you need to copy. And then you need to paste. But here you can see the file name is different. So whatever the name of your file, you need to change it. That is in this case, our file name is traits. So in place of word data, you need to type traits. After that, our observations are starting from column number 3 up to column number 13. So again, instead of 11, you need to type 13. So here also you need to change the name of file. As this R software is very case sensitive, so you have to take precautions about this file name, about small things it will give error. So after editing, just you need to press enter.
Sir, one doubt.
Sir,
after setting that setting directory, how we will import our file, sir?
So just see in your RStudio here on right side, import dataset option is there. So just you have to click on that, and the third option is there from Excel.
Okay, sir.
So if you will click on that option, like this window will come.
Okay, sir.
So then click on the browse option here on the right side, and then select the respective folder wherever you have saved the dataset.
Okay, sir. Thank you.
And after that, just import it. So after running this first command, then the next 3 lines directly you can copy and directly paste, and you can press enter. So you will get the output file in your desired working directory. So like this output file we'll get with analysis of variance, then standard error, critical difference at 5%, 1%, then genetic parameters we will get, genotypic variance, phenotypic variance, heritability. So anyone completed up to this?
Sir, now it is imported. Then next, what we have to do, sir?
Next step, go to that text file I have shared. This file I have shared. So in that estimation of genetic parameters, you have to run this first line command, whatever I have highlighted.
Sir, can you hear me?
Yeah.
Okay, in estimation of genetic parameters. After the close bracket, down under it, we have the gen variance, something like that. Are we to copy everything with it?
No, no,
Or
no.
just
Just
the first line?
see. Whatever I have highlighted now, you can see on screen. So that line only you have to highlight. Complete line you need to copy and paste, and then you need to edit that.
Thank you.
Yeah, you need to edit your file name. You need to replace this existing file name with your file name, and you need to quote from which column to which column your data set is there.
Excuse me, sir.
Yeah.
Sir, while I'm trying to import my file, it is showing that
Yeah.
you have to install higher version or improved version.
What is the version of your R software?
Sir, I installed what you gave me, that is 4.5.1.
Can you send me the whatever error you are getting? Can you share me on my WhatsApp?
Yes, sir.
Sir, can you show that RStudio screen?
Yeah. So don't be in a hurry. Tomorrow also we will continue with this only. As we need to go for interpretation also. So don't think like today we are taking, so tomorrow we will not. So don't do it. It is not like that.
Sir, just a minute, please.
Genetic
Yeah,
variants.
yeah, yeah.
Please, sir, just a minute.
Yeah, tell me.
Okay, this 3 ratio 11, what does that mean?
That means as in our Excel file, total number of columns are 13, right?
Okay.
Just you can open Excel file.
Yes.
Or else just you can see the screen. I have my RStudio is visible. So total number of columns are 13. First column is genotype, second column is replication, and from third column onwards, our data is there. So that's what the meaning is. From this 3:13 means from third to 13th column, our data is there and we need the analysis of that data. That is the meaning of that 3:13. And our file name is traits. So in that traits file, from third column to 13th column, that software needs to analyze the data and it will give us the output.
Okay.
Yeah.
Sir, tell that genetic variants and then the name change it, right? That 3:13, that and all completed, sir. The next one, sir.
Next, that command you need to copy all three. This whatever I have highlighted, just you need to copy and paste and enter. You will get the output file in your working directory.
Got it, sir. Thank you, sir.
So just check your working directory, you will get the text file. Yeah, so up to this, anyone is having any error, just let me know.
Sir, can you explain the function of the $sign that is mentioned in the code before replication and genotypes?
See, first it is what it is there. File name is threads. Data is from 3:13 column. Right? Then just we have mentioned what are the factors. As here, we have two factors. We have 44 genotypes replicated within 3 replications, right? So we have quoted like 3:13 columns. We required analysis. But what about column 1 and column 2?
Okay, got it, sir. So
column
basically,
one-
it is to mention. It is basically to take the major that we are taking, like the genotypes and replication, just to mention that
so
these two are
file
the
name
major.
is traits. It is correlated to genotype.
Okay.
Traits. It is correlated to replication, like that. It is there.
Okay. Thanks.
Okay, sir. So how do I run it now after putting in the code for the genetic parameters?
So you have completed that 3:13 code line?
Yes, but I've not run it.
Yeah.
So how do I run it?
So after that, just press enter. After completing the editing, you have to press enter.
Okay.
And after that, whatever the
Installing
3-line
error.
command I have highlighted, just you can see the screen. Whatever 3-line command I have highlighted, copy, paste, and enter it. Yeah, Dr. Sir, Selvarani sir.
Sir, but in working directory folder, I couldn't
Madam,
see.
Madam, have you set up the working directory?
Yes, sir. Sir, in D colon, I have created.
So which folder, madam, you have set up the working directory?
D.
D
colon,
directly
sir.
in D drive. So that output file will come there only, madam. Whichever folder you have set up as a working directory, output file will come there only. Just once check that D drive.
Yes, sir. In D drive, I have created a new folder in my
Okay.
name, Selva or like that. In that biometric
Yeah.
tool, one more folder I have created. Then
So
from
while setting up working directory, madam, you have to go to D drive. You have to open that first folder. Again, you have to open that second folder, and that folder you need to set up.
okay, sir. Okay, sir. Again, I will try, sir.
Yeah. Just once. Try.
So can you please share your screen?
Yeah.
Now it is downloaded, sir. One name like file genvar.
It will come in your working directory.
Yes, sir.
So you got now like this, it will come.
Mine is still telling me error.
What it is telling?
It's telling me error in genetic variance something.
So can you show your screen?
Okay. This is what I have.
Okay. So after installation of variability package, have you run the library variability command?
Yes.
Just once do one thing, run that library variability command and again run it.
Okay.
No need to copy again. Just go to that R only. Minimize this text file. No need to copy it again.
Okay.
Use the upper arrow.
Upper
That arrows are there, no? 4 arrows are there, so use the upper arrow of your keyboard. You will get the commands whatever you have earlier, ran earlier. Yeah, Soundarya Kumari, madam.
Sir, am I audible?
Yeah, madam. Tell me.
So, sir, I have one query. Like the way you calculated the genetic variability, if I'm correct, environment's genetic variability. So, how like you have to put the formula in this way? Like first you put the traits from 3 column to 13, then traits,
So
and then
actually, this will
application.
depend on arrangement of data, madam.
Okay.
This 3:13 means sometimes if you will go with some 23 or 25 characters, again that first column means that third column will be steady, because first column will be genotype, second column will be replication, that third column will be fixed, but that next column will vary, because if you will now in our Excel sheet we are dealing with only 11 traits. But sometimes in some projects, we will deal with 30 traits, 15 traits, sometimes 3 traits, 4 traits. So that column number will vary.
Yeah, its column number will vary, but how could we know if we go for to do another analysis? We have to write formula for another thing. How can I know? Like first we have to put the column number, then we have to go for the genotype,
Actually,
then
these are the
replication.
these are the codes and these are the different packages. It will depend on this as we have installed the variability package.
Yeah, that's thing I want to know. Like how.
So this R Studio, madam, this R is actually it is a package dependent software. So it has maximum, I think 9 to 10,000 different packages.
Okay.
So on that packages, there are different types of these codings.
Okay.
So that codings we need to follow.
Okay, we need to follow, but how could I go with some new package and some new coding, where should I find these things? Like I have to put the formula
Actually,
in this way.
that GitHub is there, madam. Just you can see the screen. I will share it.
Okay, sir.
So if you want to explore anything new, just GitHub is there.
Okay, sir.
So in that GitHub, you can explore anything. So you can see here some dummy codes are there.
Okay.
Yeah, so you can ask and you can do anything.
Oh, so it's a kind of Google. I have to go there and just ask.
No,
And then
in Google, simply you need to type GitHub. It is kind of database. So just you can download it also.
Okay.
Here option is there, download GitHub desktop and you can explore. Just like our genomic databases are there, different databases. So it is like a database.
Okay, sir. Thank you. I will try to do some more practice.
Yeah. That's
If
what
I have some question.
That's what I am expecting from all of you. Just explore it. As much as you can, just explore it.
Okay, sir. Thank you so much.
Sir, I'm getting some error. Can I share my screen?
Yeah. Yes, Saket. After importing dataset, you can follow the command line. for estimation of. And one more thing, some warning messages will come. So don't think about that warning messages. That warning messages will come. If your analysis is correct also, that warning messages will come. Yeah, Ragini, just run the library variability command and run the code again.
Sir, from where I can run library variability command?
In code it is there. Second line, library variability.
Sir, I have to copy this.
Yeah, copy, paste and enter. So one thing keep in mind, whenever you will install any package, you need, after installation, you need to run the library command.
Sir, it is
So that copy it, copy Control C.
Copy the install packages.
Control C, select in R and press Control V. So it will paste. Press enter. Your package you didn't install. First you need to install. Your installation is not there.
The first line.
The first line you need to copy.
Yes.
Copy, paste and enter. After installation, again, now run library command. Same that library, second line. Enter. Now run the genvar command. It will come.
So this one?
Yeah. Copy, paste. No. First line only. You need to edit it. Copy, paste in environment. Paste it. And you need to edit this.
3 to 13.
You need to change the file name. What is your file name? So you have to write there. Your file name is visible on right side. Right side. You need to write everywhere. Three times you need to change. No need to write extension. Only you need to write name.
Okay, sir. So should
Again,
I?
2 times you need to change. For genotypes, yeah.
So now I have to press enter.
Yeah. Yeah. So now after that next 3 line you need to copy and enter. Have you set working directory?
Yes, sir.
Yeah. So that next 3 line, genvar, sync and print. All the 3 line copy it. Paste, enter. So your output file will be there in your working directory. With all these analysis.
Yes, sir.
Sujata, it will take time. Sujata, madam.
Okay, sir.
It will take time. Don't worry. We will cover this. We will start tomorrow with all this again.
Sir, just a minute, please.
Yeah.
After running the genetic
Your
variance
voice is taking.
parameters, what's the next thing?
Yeah. So have you got that output file in your working directory?
No. Let me share my screen, please.
So just see here first. Before sharing, just see here.
Okay.
Have you run this first command?
Yes.
Have you run this next three?
No.
Then copy this next three, run it. You will get the output file in your working directory.
Okay.
Yeah. Yes, sir. Okay, madam. So, yeah, Vincent, sir.
I got it.
Yeah. Vincent.
Thank you, sir. Maybe I was left a bit behind. I just want to know that notepad file with commands.
Yeah. It is in
where did you
WhatsApp
check
group.
it?
You are there, huh?
Oh, I didn't check my WhatsApp group. I just focused on this.
Yeah,
Okay.
it
all
is
right.
there in our WhatsApp group. And no need to worry. Tomorrow also we will start first with this. We will complete interpretation tomorrow up to this variable genetic parameters. After that, we will go for correlation and path analysis. And one request to everyone should join maximum up to 6-5. Okay? Because again, if you will join 615, 620, so you will lose that portion. So I know many people are working, but please try to join by 6-5. So in emergency case, no problem, but it will save our time. And we can cover the maximum portion, maximum your doubts. So from tomorrow onwards, we will start at 6-5.
Excuse me, sir.
Yeah.
Sir, output file will come as Word file or
No,
simply as it is giving text?
Output file will come in text document. So tomorrow I will tell how to import in Excel.
Okay, sir.
Yeah, Adil Ahmed, sir. In interpretation part, I will tell each and every terminology, so no need to worry.
Thank you, sir.
So total in detail, yeah.
Actually,
So
sir,
total
I
in
am from
detail
statistical
interpretation you
background.
will get. Yeah, I know.
Okay, sir. Actually, sir, I am not getting the term like
Your voice is breaking.
phenotype. I have not stated.
No problem. I will try to clear maximum concepts as much as I can. Yeah, so tomorrow we will start with the estimation of genetic parameters. After that, we will cover interpretation. After that, we will go for correlation and path, and after that, interpretation. So this thing tomorrow we have to cover. Meantime, I will share in the morning hour. I will share the different data sets that will be useful for evening session. So it will save our time. What are the different packages you need to install? That also I will share. Those who will get errors we will solve in this session, but just try to install each and every package. So that will save our time. Okay?
Thank you, sir.
Thank you, sir.
So yeah.
Will you send us the recording today?
So recording, we need to ask. Yeah, Bibakar sir. Hello.
Hello. Sorry, sir. I just want to check with our tool that you said we can also install. What's the significance of that? And also, when I click
R tools means it is like one of the base. It will help the different packages to run smoothly.
okay, so it says choose your version of our tools. So we choose which one? 4.5.
So say whatever, our software version is 4.5. So you need to choose the R tools also 4.5.
Okay, thank you, sir.
Yeah, Bibakar sir, what about they are asking whether they will get daily recording sessions or what?
Okay,
Weekly they will get, sir. I will update in the group, sir, very soon. How they are going to get.
Yeah.
Please,
So
Prof, will you send
shortly,
the recording and the lecture material today so that we can go over it again before tomorrow?
Okay.
Thank you.
yeah, Maya Chandra.
Yes, sir.
You are getting error model frame default. So have you changed the names of the file?
Yes, sir. I have changed the name of the files. Once I run the code initially, it was done.
Can you share the screen? Can you share this your screenshot on my WhatsApp, personal WhatsApp?
Yes, sir. I can share it. I'll share it, sir.
Yeah, I will. Yeah, I will tell you solution there. No problem.
Okay, sir.
Yeah. Okay. Bibakar sir.
Yes, sir.
Yeah, so I have already told them that tomorrow at 6:05 we will start the session. I told them to join at least 6:05, not after that.
Okay, sir.
Okay, so thank you everyone for joining.
Thank you, sir.
We'll meet at
Thank
6:05
you,
tomorrow.
sir. Yes, sir.
Yes, sir.
Thank you, Bibakar sir.
Yes, sir.
Thank you, sir. Shekhar,
Thank
sir,
you,
are you
sir.
there?
Thank you, sir. Please help us
Yeah,
send the recording and the lecture.